Hi, and welcome to our video on simplifying radicals. Just to start off, a radical is what you guys know as a square root sign. So anything that has a square root sign is considered a radical. So you could also say radical 4, which we all know is, the square root of 4 is 2. Okay, so we all know that if we have something like the square root of 4, we know that that is 2. And the square root of 9, that is equal to 3. And the square root of 16 is equal to 4. And we know that that's true because 2 times 2 equals 4, and 3 times 3 equals 9, and 4 times 4 equals 16. Okay, so that's just the basic premise of square roots, which I think you guys know. So let's talk about a couple of the properties of working with radicals. So let's say we've got something like the square root of 2 multiplied by the square root of 3. Okay, the commutative property says that you multiply them and they both can come under the radical like this. So the square root of 2 times the square root of 3 becomes the square root of 2 times 3, which is equal to the square root of 6. If you had the square root of 3 times the square root of 7, that's the same thing as the square root of 3 times 7, which is equal to the square root of 21. So if you just came up with a basic rule, it basically means that the square root of any number a times the square root of any number b is equal to the square root of a times b. Okay, this is just a property showing you that you can multiply two radicals together and the product just stays underneath the radical sign. Okay? All right, so now let's talk about simplifying radicals. So if you have, like we said, the square root of 4, we know that that's equal to 2. Okay, we could also break it down into the square root of 4 equals the square root of 2 times 2. Right? We could also say that that's the same thing as the square root of 2 times the square root of 2. Right? There's a lot of different ways to write that. Okay, so now we're going to talk about simplifying radicals that are not perfect squares. So let's say we've got the square root of 8. So basically what you want to do is you want to try and break that into factors that have a perfect square. So we know that we can do the square root of 8 as being 4 times 2. See, all I'm doing is I'm using my rule backwards. I'm going from here to here instead of vice versa like we did before. So now, using the rule from before, I can say that is equal to the square root of 4 times the square root of 2, and the square root of 4 is 2, and it's multiplied by the square root of 2. Okay, let's do another example. So let's do the square root of 18. Right? So we got to think about any factors that 18 has that's a perfect square. We know that 9 times 2 is 18. So that means that's the square root of 9 times the square root of 2. And we know that the square root of 9 is 3, and that's multiplied by the square root of 2. After you start doing this, you'll kind of start thinking in a way in which you'll just be able to do it automatically. But for right now, it's good to go ahead and just write everything out. So let's say we've got the square root of 75. Okay, we know that 75 has factors of 25 times 2, and that's the same thing as the square root of 25 times the square root of 2. The square root of 25 is 5, and the square root of 2 can't be simplified anymore. All right, so all we're doing is we're putting it into a simpler form. And when you start doing more things later on in the course, having it simple like this will make a lot more sense. Okay, so let's just do one more. Let's say we do the square root of 300. Okay, so remember, all you're doing is thinking to yourself, what is a perfect square that is a factor of 300? Well, we know 100 times 3 is 300. So square root of 100 times the square root of 3 equals, square root of 100 is 10 times the square root of 3. Okay? All right, so let's go on to something a little different. All right, here's another property. If you have, let's say, 2 squared, you know that means 2 times 2. If you have, let's say, x squared, you know that that is x times x. If you have xy, the whole quantity squared, right? You know that that's x or yx times yx, which is equal to y squared, x squared, right, by the commutative property. Okay, so now we're going to talk about what happens when you square a radical. So let's say we have the square root of 2 and that squared, right? So that basically means the square root of 2 times the square root of 2, which, following our rules that we just learned, can be the square root of 2 times 2, which is the square root of 4, which equals 2. Okay, now I'm going through a lot of steps here just to kind of show you where you get from the beginning to the end, but then we'll do a really easy way. So the square root of 7 squared, that's the same thing as square root of 7, times the square root of 7, which is the square root of 7 times 7, which is the square root of 49, which is 7. All right, all that work. So let's figure it out. That just basically means that the square root of any number squared is just equal to that number, right? We started here with 2, and we ended up with 2 over here. We had the square root of 7 squared, our answer was 7. And then here, the square root of a squared, and our answer was a. So that just basically means that any number under the radical squared, you're just basically pulling it out of the radical. So if we did the square root of 37 squared, it would just be equal to 37. Okay, it's just something that you'll have to learn and practice with. Okay, now you can do something a little different also, where you've got not just a square root. Let's say you've got 2 times the square root of 3, and that whole quantity squared. Okay, so that means 2 times the square root of 3 times 2 times the square root of 3. So while this right here, the square root of 3 and the square root of 3 is equal to 3, you still have to multiply 2 times 2, which is 4. So 4 times 3 is 12. Okay, let's do another one. Let's say 3 times the square root of 2 squared. So basically you're squaring each individual factor. So it's 3 squared times the square root of 2 squared. We know that 3 squared is 9, and the square root of 2 squared is 2, which is equal to 18. Okay, let's say we've got 7 times the square root of 6 squared. All right, so that basically means 7 squared times square root of 6 squared. So 7 squared is 49, and square root of 6 squared is 6. And I gave myself a big number, so 49 times 6 is 294. Okay, so just remember, whenever you're squaring a square root that has a factor next to it, you're going to square that factor and then also the square root. All right, one last thing. All right, you guys all know from algebra that it's a big no-no to have 0 as a denominator because it becomes undefined. Well, the same thing's true if you have a radical as the denominator. So let's say we've got 2 divided by the square root of 3. Okay, we don't want that square root of 3 there. That's not good, so we need to get rid of it. So remember, when you multiply, this is basically a fraction, 2 divided by the square root of 3, or 2 over the square root of 3. Whenever you want to change a fraction into something else but not change its value, you multiply it by 1, some value of 1, okay? But in this case, since we want to get rid of this radical, the way to get rid of the radical is to multiply it by 1, okay? This right here is equal to 1, but what's going to happen when we multiply the square root of 3 times the square root of 3? It's going to go away. Right? So 2 times the square root of 3 is 2 times the square root of 3. And the square root of 3 times the square root of 3 is 3. So all we've done is we've gotten rid of that bad radical. Okay? Let's do another example. So let's say we've got, let's say 4 times the square root of 2. Oh, no, let's do a different one, sorry. Let's do 4 divided by the square root of 2. Okay? We don't want that square root of 2 on the bottom, so we need to get rid of it. This is called rationalizing the denominator. So we're going to multiply it by 1, right? Because square root of 2 over the square root of 2 is 1, because any number over itself is 1. So we know that 4 times the square root of 2 is just 4 times the square root of 2. 2 times the square root of the square root of 2 times the square root of 2 is just 2. All right, and now we can just simplify. 4 divided by 2 is 2, and we still have the square root of 2 left. Okay, and let's do one more. Let's say you've got 2 times the square root of 3 over the square root of 2. Okay, in this one, we've got 2 radicals, but the only one we want to get rid of is the square root of 2 because it's in the denominator. Okay, so we're going to multiply that by the square root of 2, because that's going to get rid of it. Okay, so remember our rule from before. If you multiply 2 radicals together, you're just going to multiply 3 times 2, and the product will go underneath the radical sign. So it'd be 2 times the square root of 3 times the square root of 2 is the square root of 6. And the square root of 2 times the square root of 2 is 2. And then, of course, 2 over 2 simplifies, and we're just left with the square root of 6. Okay, I know this is not a difficult thing, but it does something new, something you guys haven't seen. It's just going to take practice. So we'll do some practice in class. This was just a video to kind of help you get a little bit better understanding. I guess I will see you guys in class tomorrow, and have a good night. Bye-bye.